Okay, so qualitative data, if you recall, is data that is measured in terms of categories. So and it could either be nominal or it could be ordinal. This is from last time. So but one thing that we are certain about is that categorical data or qualitative data, they're not numerical in nature. So how do we organize it? By organization, I mean, how do we get some sort of knowledge from the data that we're looking at? The key word here is looking at the data. So we're talking about visualization, and typically visualization is an easier way to understand the data and get some information about the data. But before visualization, there is this intermediate step called grouping, which involves the creation of a frequency distribution. So the frequency distribution simply would tell us the frequency of a particular level in a categorical data set. So once we know the frequency, then we can tabulate it in the form of a table. And using that table, we can come up with charts that can be used to visualize the data. Now, you must have known, or you probably know, the two commonly used graphs for qualitative data are a bar graph and a pie chart. So a pie chart is easier to understand. Most of you know what a pie chart is, and many of you probably also know what a bar graph is. But I want to explain bar graph before we can move forward, because bar graph is related to what we call a histogram that we will encounter in organizing quantitative data. So as an example, let's just say, let's just consider the data consisting of types of shepherd dogs. Let's say in a kennel, And let's have Australian, German, and a pure white shepherd. And let me call it as A, G, and M. So these are simply nominal levels of measurement. And this is the data that we have. So let's just say that's what we observed in the kennel. Just by looking at it, it might seem like a large data sample, but if I organize it, then perhaps I would, or not perhaps, definitely we would get a better idea about the number of dogs, the type of shepherds that are in the kennel. So I'm going to start with the type. I have 3 levels or 3 categories. So A, G, M. And I'm going to create, or I'm going to count the number of observations that fall in each category. So first I'm going to start counting the A's. So I have 1, 2, 3, 4, 5, 6, 7. The G's, I have 1, 2, 3, 4. The M's, 1, 2, 3, 4. So in total, we have 15. That tells us the total number of shepherd dogs in the kennel is 15. And the table that we just created is what we call a frequency distribution. So there is another distribution which is called a relative frequency distribution. It is different from the frequency distribution in the sense we have the frequencies for each category, A, G, and M, and we're going to take each frequency and we divide it by the total number to get the relative frequency. So A, we have 7. So the relative frequency corresponding to that would be 7 over 15. G, we have 4. So the relative frequency corresponding to G would be 4 over 15. And lastly, M is also 4. So we would have 4 over 15. So since we divided everything by 15, well, of course, the total will get divided by 15 too. So if we add all the relative frequencies, we should end up getting 1. So what is the purpose of having the relative frequency? It sort of gives us the exact percent just by looking at the frequency distribution. So I can say, well, I have 7/15. So approximately 49% of the dogs in the kennel is an Australian Shepherd. And I could make a similar conclusion about the others. 4/15 is approximately 24. And likewise, 4/15 for the other case would also be approximately 24. I think it should be slightly higher than 24. That's 26. Okay. And if we add everything, it'll probably come to 1. So I'm just putting approximately for now because I'm not using a calculator. So once we have a frequency distribution, we can create what we call a bar graph. We can also use a pie chart. If you drew it in a circle and put AGM, we could have 49% for A, so that's about nearly half. So I could say 49% for A and 26% and 26% approximately for the other two breeds. And that would be a simple pie chart. Now, a bar graph would take the frequency distribution or the relative frequency distribution, and it is going to represent each of those percentages of frequencies using bars. So the general procedure behind organizing qualitative data is to collect the data first, group the data, and the last step is to visualize, and you could visualize using a bar graph or a pie graph. The most commonly used one, however, is the bar graph. So what we see here is a bar graph that tallies the frequency in thousands, that's in the y-axis, and the ethnicity is in the x-axis. And what are we measuring? So we are measuring the number of people in poverty. So the Census Bureau uses money income thresholds to define poverty. So each year they have a poverty threshold. So in 2013, a family of 4 with 2 children, it was 23,264. And the bar graph represents the number of people living in poverty in the United States in 2013 by ethnicity. Just by looking at the graph, we can answer a few questions. So first, how many whites were living in poverty in 2013? So we have the frequency listed in the graph itself, and it is 29,936. So of all the impoverished people, what percent were Hispanic? So could we convert this bar graph to a frequency distribution? In other words, could I go in reverse? So I easily can. So we have ethnicity and white, black, Hispanic, and Asian. We have the frequency that is listed to us for each case. That's 29,936 for whites, 11,041 for blacks. That's weird. It's 12,745. That is the correct number there. And 1974 for Asians. So if we tally all of those values, we will get the total number of people that we used to use in the study to make inference. So we could add all of those numbers to get the total. So 29,934 plus 11,041 plus 12,745 plus 1974, it comes to 55,694. The relative frequency is going to give us the exact percent. So typically we can round it to about 2 decimal places. So what we have to do is to take each frequency, which is 29,900. Oh, I'm sorry, it's 6, not 4. Divided by 55,696, 11,041 divided by 55,696, 12,745 divided by 55,696, and 1974 divided by 55,696. So each of those will give us a corresponding percentage. The first one is 0.53748. I can round it to 4 decimal places. So the answer would be 53.75%. The second case is for blacks. That comes to 19.82%. The third case would be Hispanics. So I'm just multiplying it by 100. I'm taking each of these frequencies and rounding it to 4 decimal places, multiplying it by 100 to get the percent. And the last case would be 1974 divided by 55,696. So Now that we have a relative frequency, we can answer part B. So of all the impoverished people, what percent were Hispanic? We could say 3.54%, excuse me, sorry, 22.88%, which belongs to the Hispanic category. Now, how might this graph be ways? There are other ways to misinterpret the graph, in the sense you could take this graph and extend it to every single year. So you may say, oh, I have this information, so this must be true for 2014, 2015, 2016, and so forth. That is just not true. So those are the two common ways in which you can misinterpret this graph. But the first one, where just by looking at the counts that are listed on top of the bars, one may say, oh, that just corresponds to the poverty threshold. But in reality, that corresponds to the number of people who were below that poverty threshold. So a random sample of 2,163 adults aged 18 and over was asked, when you see an ad emphasizing that the product is made in America, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? So the result of the survey is presented in this side-by-side bar graph. Now, it is a bar graph, but here we have multiple categorical variables. So there are two categorical variables in this bar graph. It's called a multivariable bar graph, or a side-by-side bar graph. So the first categorical variable is the age group. And the age variable is measured in (18 to 34, 35 to 44, 45 to 54, and 55 and above. So there are 4 levels, hence the 4 different categories here. But within each level, we have 3 options. So the second categorical variable is the response. More likely, less likely, or neither would be the next categorical variable. Since we have 2 categorical variables, we need a nicer way to represent the data as a graph, or visualize the data. And that's why we have the side-by-side bar graph. As I mentioned, people call this multivariable or multivariate bar graph. Some would call it a stacked bar graph if you use Excel. In Excel, this is called a stacked bar graph, because we are stacking different levels together. And some might have it as vertical, like you see it, or if you flip it, you can have it in as a horizontal stacked bar graph. But it doesn't matter how you visualize the graph, as long as you can understand what the graph says, then we're all good. So the first question here is, what proportion of age 18 to 34-year-old respondents are more likely to buy when made in America? So first, we need to look at the percent. So first, we've got to go to the 18 to 34-year-old respondents. which is the first case here. And in that group, we need to ask for or look for the proportion. Proportion, relative frequency, percent, they all mean the same thing. So when we say proportion, we're talking about the relative frequency or the percent. So more likely to buy when made in America. So if you look at the legend here, that box is called the legend box. The legend tells us the blue one would be more likely. So the blue here is about 45. So the answer would be approximately 'Excuse me. So I can get the percent directly because the y-axis here is not a frequency count, rather it is a relative frequency, similar to what we did in the last problem. But in the last problem, we had to compute the relative frequency using the frequency distribution. But in this problem, the relative frequency is given directly to us. The second question, what proportion of the 35 to 44-year-old respondents are more likely to buy when made in America? So 35 to 44 would be the next level here, and more likely would simply mean we have to look at the blue bar. The blue bar goes slightly over 60, I might say about 61%. It's right here. It's approximately 61%. So I could conclude and the question in part B wants to know which age group has the greatest proportion who are more likely to buy when made in America. So now we have to look for the blue bars and look for the greatest age group. So I'm going to look at all 4 age groups. The first one, it is right here. The second, it's right there. The third age group is right there. And the last one, 55 plus, is right over there. Only by looking at the blue bars, which correspond to the more likely case, we can see that for the age group 55 and above, if the ad says made in America, that group is more likely to buy. So the tallest bar happens in the age group 55 plus. So the 55 plus age group is the group that that is more likely to buy when Made in America ad is specified. So let's consider the same problem, and let's see. So we have group, which is the age group, and the response category is one of those three. It's either more likely, less likely, or neither. So I've picked 18 to 34. I'm going to pick 45 to 54. The last one, 55 plus. Less likely and neither. And we need to know the percentage for those three cases. In other words, in the 18 to 34 age group, what are the chances that an ad has no effect when it says Made in America? That's what a neither response would mean. In the age group 45 to 54, when they say Made in America, what are the chances that they would be less likely to buy the product? And in the age group 55 and above, what are the chances, or what is the proportion that people wouldn't care if it said Made in America or not? In other words, a neither response. So we look at the graph, and 18 to 34 would be the first block, and in that, neither would correspond to that bar, and it is about 3%, maybe 2%, so I'll just call it approximately 2.5%. 45 to 54, less likely, would correspond to the green bar, which is right over here, and it's exactly at 30%, so 30%. And lastly, neither in the 55 plus group, it's about 2%, so we'll call it approximately 2%. So just by looking at this graph, we can get information as to how different age groups would be affected by an ad when they see Made in America or otherwise. Some are more likely, some are less likely, and some it really doesn't matter. And from the graph, it is very clear that the percent of people who don't mind at all is always very small. If you look at the orange bars, it is very tiny in all age groups. And in all age groups, when we see Made in America, it makes us to buy the product rather than saying, oh, I'm not going to buy the product, because the less likely bar is not that high. Except when it comes to the 18 to 34 group, where if it says Made in America, they seem to be affected by it, because they are not more likely to buy, rather they would just buy when it doesn't say Made in America. So the only group that is standing out from the other three groups would be the 18 to 34 age group. So here we have a survey of US adults and teens The teen ages are 12 to 17. The survey was conducted by Pew Research to determine the number of texts that students would send in a day. So the number of texts is given in the table. So we have 1, 2, 3, 4, 5, 6 levels. And even though they are categorical, these are ordinal levels of measurement, because we're going from none, which is 0, to 1 to 10, and then 11 to 20, and so forth. So this would be ordinal levels of measurement. So we have two groups. The two groups are the adult group and the teen group. So what we have to do is we have to construct a relative frequency distribution for adults and a relative frequency distribution for teens. So I'm going to show you how you can easily create a relative frequency distribution without typing things, each level for none and 1 to 10 and so forth. So the most important buttons in the calculator are the start button, which is right below the delete button, and the blue button would help you access functions corresponding to the blue functions that are listed above each button. For instance, above the start button, in blue, you have list, which would imply to access a list, we have to press second, then press the start button. So start button obviously stands for statistics. So I'm going to hit start. I'm going to press 1, and in the first list, I'm going to enter the adult count. So I have 173 for none, 978, 249, 249, 134, 153. So I have entered all counts for adults and I've saved it in list 1. Press the blue button, which is second, and hit mode, which would mean quit. So you'll just clear out your screen. Now, if you press start, go over to calc, which stands for calculate, select one variable statistics, and press second 1. If you have the newer version of the calculator, your screen might actually look slightly different. In the sense, the newer version would probably have list, freq, and paste or calculate, one of those. So in the list field, you would just enter list 1. So I'm going to write it on the side here. So if you have a newer version of TI 84, it should say list, freq, and calculate when you press one more stats. One more stats stands for one variable statistics. So instead of pressing second 1 like I did directly, you would go to this field right there, enter second 1, you will get L1, and hit enter to skip the frequency part, and hit enter again. You will see calculate highlighted, and hit enter again, you would get the answer. So if you have the older version, it's just one variable statistics, second one. So I'm going to hit enter. In the second row, we have 1936. So the sum x that you see in the second line that simply is the total number of adults that were in the survey. So we have 1936 over there. Now I could easily compute the relative frequency distribution the moment I know the total. So all we have to do is go back to start. Number one, press the right arrow to move to list two, and press the up arrow to move to the column header. Now enter second one divided by 1936, which is the total. Hit enter. It automatically summarizes the values for adults. So what is the relative frequency distribution for adults? So we have none, 1 to 10, 11 to 20, 21 to 50, 51 to 100, and 100 plus. The relative frequency, I saved it to list 2, so 0.089. If I round it to 4 decimal places, 36 would simply be 4. Then I would have 0.5052, 0.1286, looks like I'm missing 1 to 10. Sorry. Go up 1. So none is 0.0894. 1 to 10 is 0.5052. 0.1286, 0.1286, 0.0692, 0.0790. So if you use the list, you can directly compute the relative distribution easily instead of summing everything and typing 173 over 1936 and 978 over 1936 and doing it one frequency at a time. So this is an effective approach. In addition, knowing how to use these lists are quite helpful when it comes to doing the homework and when dealing with quantitative data and computing measures of center and spread and position in chapter 3. We can clear everything that we entered by pressing start. Go to number 4, which stands for CLR list. Press second one, and it is going to pop up list 1. The comma button is right above 7. So press comma, second 2, it'll have list 2, enter. Second mode to exit. If it works. And if you go back to the table, everything that you entered is now gone. So you can clear the table and you can restart. So previously we had the 1936, that was the total for adults. What I'm going to do is I'm going to enter the frequencies for teens in list 1. So I have to press start 1. So I get list 1, list 2, list 3. So in the first list, I'm going to enter the frequencies. So I've got 13, 138, 69, 113, 113, and 181. So now that we have all the list 1 values, we want to find the sum of all of those frequencies. So to do that, I'm going to press second mode, exit out, press start, over to calc, select 1, which is 1 variable statistics, second 1, which would bring up list 1. If you have the newer version of the calculator, do keep in mind that you would have to enter it in a slightly different way. In case you get lost, you can always come back and watch this video, or if you look in the back of the textbook, at the end of each chapter, there are instructions on how to use the calculator to get the frequency and so forth. So I'm going to enter to get the sum 14 as 627. So 14s we know the total sum now is 627 for the teen group. So I'm going to press second mode or the clear button. Press start, press 1, edit, go over and up. You will have the header selected. Now press second 1 divided by 627. In other words, you're going to take every single number in list 1 and you're going to divide it by 627. Hit enter. So for the none category, we have 0.0207. The next one, we have 0.2201, 0.1100, 0.1802, 0.1802, and 0.28868. I'll call it as 7. I'm going to round it to 4 decimal places, so it's 0.2887. So that is the table that we created, and now they want us to construct a side-by-side relative frequency bar graph. So I'm going to use red for the adult group and blue for the teen group. So in practice, we're not going to do this manually. Most statistical software will show you or will give you the graph easily, but we're doing this right here so that we can understand the concept. That is all. So 1 to 10, 11 to 20, 21 to 50, 51 to 100. Need more space. And 100 plus. And the y-axis is the relative frequency. The highest value is about 0.5052. In other words, it's about 50%. So let me increase in steps of 5%. Kind of crammed up. I'll just do it in 10% increments and we can deal with it later. Excuse me. So those are the relative frequencies on the y-axis. So we will start with the adult group. So for the number of adults who said they don't send any text at all, that was about 8.94%. So probably right there. And 1 to 10 texts, about 50%. And 21 to 50, 11 to 20, we have 12.86%. And 21 to 50, it is the same level. 51 to 100, about 6%. 100 plus, about 8%, so slightly higher. And those are the bars for the adult group. So the teen group, no text at all, it's about 2%. 1 to 10 texts, that's about 22%. So 11 to 20, we have about 11%. So 10, slightly higher than 10. 21 to 50, we have 18%. 'Same for 51 to 100. And 100 plus, we have 28%. And of course, I could put the legend. So blue would mean the teen, and red is adult. So that is the side-by-side bar graph. And what kind of inference can we make once we visualize this? Well, just by looking at the picture, I can conclude that majority of adults send about 1 to 10 texts per day, because the tallest red bar is between 1 to 10, and the red bar would correspond to adults. And the majority of teens would spend or would send more than 100 text messages per day, because the tallest blue bar is for the 100 plus group. So it seems like, in a cumulative way, majority of the teens would send at least 21 or higher, 21 or more text messages per day. And that information, some can get it directly from the frequency distribution, but we can always convert the frequency distribution to a side-by-side bar graph and make an inference using the bar graph. Again, we don't have to create this manually. Software these days can get it to us easily. And instructions to do this in Excel, StackCrunch, or other software is also available in the back of the textbook. So this is a problem where there was a survey that was conducted to determine the favorite day to eat out. The survey was conducted by Wakefield Research, and the participants were asked to disclose their favorite night to order takeout for dinner. And the data is below. We have days. We don't see any, there is Monday also. So let's just do all 7 days. So we have a categorical variable. The categorical variable is the day. So it has 7 levels of measurement. And our first job is to construct a frequency distribution. So Okay, so all we have to do now is to count the number of observations for each of those days. Let's go back to the data. The data that we have is not grouped, it is not organized, it's in its raw form. Now we're going to convert it to a frequency distribution to have it organized. So Monday, there is 1 in row 3, 2, another 1 in row 5, and that is all I see. So Monday we have 2. Tuesday there is 1, 2, 3, 4, 5. Wednesday we have 1, 2, 3, 4, 5, 6. That's it. Thursday 1, 2, surprisingly only 2. Friday we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And Saturday we have 1, 2, 3, 4, 5, 6, 7, 8. Sunday 1, 2, 3. We can add all this to get the total sample size. So we have 22, 25, 30, and in total we have 40. So that simply is the frequency distribution. To get the relative frequency distribution, we just have to take each level and divide it by 40. So we have 2 over 40, which would be 0.05, 5 over 40, 0.125, 6 over 40, it's 0.15, is it 0.15? Yes, and 2 over 40, 0.05, 14 over 40, 0.35, 8 over 40, it's 0.2, and 3 over 40, it's just 0.075. And if we add all the relative frequencies, we should get 1. So the next question wants to know, if you own a restaurant, which day would you purchase an advertisement in the local newspaper? Are there any days you would avoid purchasing advertising space? So you look at this table, the most frequent day when people like to go for takeout is on a Friday. So Friday, the 35% of people who get takeout go for a Friday. So if I was a restaurant owner, or if you were a restaurant owner, based on this survey, if you want to spend money, you'd spend it on a Friday. This way, people are more tempted to buy takeout on a Friday. So the days when you don't want to advertise typically should be on a Monday or a Thursday, because only about 5% of the people would want takeout on either a Monday or a Thursday. So if I was the owner of a restaurant, the day I would purchase ad space on the local newspaper would be on a Friday. So the next step is to create a frequency graph, which is simply a visualization of the frequencies. The y-axis would be the frequency and the x-axis would be the day of the week. I don't want to write Monday, Tuesday, Wednesday entirely, so I'll just call it as M, T, W, R, F, S, S, U. So Monday, highest is 14, so let's go in steps of 2. Monday, we have about 2, so Tuesday, we have 5. Wednesday, we have 6. Thursday, we have 2. Friday, we have 14. Saturday, we have 8. Sunday, we have 3. So that is the frequency bar graph, because we use the frequencies on the y-axis and day of week on the x-axis. Now, the only difference between a frequency bar graph and a relative frequency bar graph is that the y-axis in a relative frequency bar graph is not frequency, rather it is relative frequency. And we have to have the y-axis in percentages. So I'm going to have 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, 0.35. So Monday, the percent is 5%. Tuesday, 0.125%. Wednesday, 15%. Thursday, 5%. Friday, 35%. Saturday, 20%. Sunday, 7.5%. So that simply is the relative frequency bar graph. Excuse me. But if you look at the frequency bar graph and the relative frequency bar graph, there are no differences whatsoever in terms of the shape of the bar graph. The shape is something that is very important when it comes to data analysis. What do I mean by shape? It wouldn't make good sense to talk about shape with bar graphs, but it is a good lead in to what we would do with quantitative data. By shape, I mean, if I simply put a dotted line, I will get something like that. Same over here. And you can see that the two shapes pretty much are the same in terms of the bar graph. So knowing that underlying shape is very useful with quantitative data. With qualitative data, such as the one we have here, it's not that useful, but do keep in mind of the word shape. It is something that we need to observe in data when it comes to analyzing data using statistics.